I got a lot of homework questions from sections 8.1, 8.2, and 8.3, so I'm just going to go through all these problems really quickly and send these out to the people who asked me questions, and we'll see how it goes. So yeah, if you're only looking for one or two of the questions, I will have bookmarks down in the, so you can skip around to find the problem you like in the, mouse over the video, and it should have little segments so you can pick out the right problems. So let's see how it goes. First one is 8.1, number 3. Number 3 gives you a table of values and says, is this a linear function, a nonlinear function, or it's not even a function? So the key thing is that to first see if it's a function or not, if you have if the same x appears twice, and goes to two different y's, it's not a function. This is called the vertical line test. It's weird to call it the vertical line test for a table, but if you think about what a vertical line tests, it goes through one x and tries all different y's for the same x. So if the same x goes to multiple y's, then it's a non-function relationship. The one I'm looking at is fine. It has all the x's are different. Each x is going to only one y. Then to see if it's a linear function, each time x goes up by 1, y goes up by the same amount. It has a constant slope. So when x goes up by 1, y goes up the same amount. It doesn't have to go up by 1, but like the y has to change by the same amount every time x goes up by 1. That number is called the slope. It has to be the same slope everywhere. And then nonlinear is if the slope is changing. So these are the three possibilities for this question. Let's take a look at what I have here. The example that I have up in the corner, I have 3, 4, 5, 6, 7 for the x's. So the x's are all going up by 1. And then the y's, I have to see if the y's are changing by the same amount each time that x goes up by 1. So x went up by 1, y went down by 1. X goes up by 1, y went down by 1. X went up by 1, y went down by 1. This is a linear function where every time x goes up by 1, the same thing happens. Let's see if I can get one where something else happens. So this one, the x's are all different, so it's a function. But then is it a linear function or a nonlinear function? Well, x goes up by 1, y goes down by 6. X goes up by 1, y goes down by 6. Okay, I got another one that's a linear function. If you got one where the x's were going up by 1, but the y's were going up or down by different amounts each time, that one would be a nonlinear function. That's 8.1, number 3. Next one. 8.1, number 5. Number 5 says, give the domain using interval notation. The domain, remember, is all the x's, all the possible inputs. To a function. So the reason, you might think, what do you mean? I can plug whatever I want into a function. You can't stop me from plugging in 7. And the issue is the function might have some problems where if you plug in 7, the function might not be able to handle the number 7. Maybe plugging 7 into the function makes the function divide by 0. It can't do that. Maybe plugging in 7 makes the function take the square root of a negative number. There's all kinds of things that can go wrong in a formula if you plug in the wrong x. The domain is all the right x's, all the possible inputs that you can plug in. So for the problem I'm looking at, I go look at this fraction and I say, oh, look at this function. What x's could I plug in, or what x's could go wrong? It's always okay to divide by 6. So for the one I'm looking at, for 5x plus 18 over 6, it's a fraction. The only thing that could go wrong would be if the denominator was 0. But that never happens. So x can be anything. If you plug in 0 or 12 or -7, it doesn't matter. You'll always get to plug in the number, do some calculations, divide by 6, and everything will be fine. The issues would come up if there were x's in the denominator. If there were some x's in the denominator, we would have to watch out and say, wait a minute, let's make sure that we keep out the x that would make the denominator equal 0. Here though, x can be anything. To write anything in interval notation, I do it the same way I do everything in interval notation. I draw a picture of the number line and shade in all the spaces that I want. Here I want all the spaces, and then I can go from left to right across my picture. This one starts at -infinity and goes up to infinity. Finally, I have to decide whether to put parentheses or brackets. Infinity and -infinity are not even numbers, so they cannot be included in the interval. So I will use parentheses. If the endpoint was included, I would have used a bracket. So my answer here is everything from -infinity to infinity. Interval. I want parentheses. I want -infinity, comma, infinity. If you ever get a problem that asks you to deal with a function that sometimes might divide by 0, then you might get a totally different answer. Okay, next up is number 8. Oh. Okay. 8.1, number 8. Number 8 says, take the description of the function, it's like a rule written out in English, and process it. Make it into a table and make it into a graph. Let's see how that works. So this function that I'm looking at says, the function j of t multiplies the input value by -4, then adds 5. Okay, well, the input value here for j of t means that t is the input. So I need to multiply the input value by 4. So I'll multiply t by 4. Oh, it says -4. Multiply the input value by -4, then add 5. So this is my formula. In the table, I just take each of those input numbers, I multiply them by -4, and I add 5. You can either use the verbal rule or you can use the formula, and they both work. They give you the same answer. So I need to take all these numbers, like -2, multiply by -4, that's 8, and add 5, that's 13. If I do that to all these numbers, I'll fill in this whole table. So multiply by -4 gives me 4, add 5 is 9. Multiply by -4, that makes it 0, add 5, that's 5. Eventually, for a linear function like this, you might start to see the pattern that all these numbers are just going down by 4 each time. Once you notice the pattern, follow the pattern. That's fine. Then an ordered pair is a pair of numbers. That's why it's called an ordered pair. And the ordered part means you put the input first and the output second. So the only thing that can really go wrong here is try not to confuse this with interval notation. In interval notation, the first number means like the x value on the left, and the second number means the x value on the right. Here, an ordered pair, the first number is the x, and the second number is the y, or the first number is the input, and the second number is the output. So that's the difference. To get a graph of it, this is a linear function, so I can just pick my favorite two of these points and draw a line between them. So I click this little thing, and I say, I'll go through 0, 5, and 1, 1. I could technically plot all these other points, but you only really need 2 points to graph a line. Finally, our formula for the function was, the main thing is that a function it tells you that one thing is another, so it has an equal sign in it. If you write minus 4t plus 5, it's going to have a complaint. And the complaint is pretty good. The complaint is, this is not an equation. Give me an equation. Well, the equation is that the output is minus 4t plus 5. Here it's that j of t equals minus 4t plus 5. So that's that. Cool. Next up is 8.1, number 9. It says graph the equation, and here's the equation. Now, the main thing you need to do to be able to graph this equation is plug in x's and get y's, which are these f of x. Now, if you know something about the function, you might decrease the number of points you have to plug in. But worst case, you could always just plug in like 12 points and then plot them, and something would happen. I recommend that you try to guess in advance a little bit more what kind of shape it's going to be. And here, this is f of x equals minus a half x minus 4. Because the x is just to the first power, it's just multiplied and subtracting by some numbers. This is a linear function, so the picture will be a line. So I notice that y equals minus 1/2 x minus 4 is a line. And that's useful because I know that I only need 2 points to graph a line. So you should have in the back of your mind, like, well, worst case for any function, I could just plug in 13 points and plot them all, and I'd probably get the graph. But we can do a little better than that. If we know what kind of graph it is, here it's a line, then that tells us how many or what kind of points to plot. Knowing that it's a line saves us a whole bunch of effort. I just need 2 points. So I plug in my favorite 2 x's. You can pick anything you want. If you get to pick any number you want, I recommend 0. You might as well be nice to yourself. When x is 0, it gets multiplied by minus a half. Multiplying by 0 kills a number, makes it 0, and you're left with just minus 4. So when x is 0, y is minus 4. Now continue to try to make your life easier when you get a choice. Here, you might choose x equals 1, but that makes your life a little bit harder because then there's a fraction, 1/2, that you have to deal with. You get to pick any x you want, so pick 2 to cancel out the 1/2. When I plug in 2, I get minus a half times 2 minus 4, and that's minus 1 minus 4. In total, that's minus 5. So I have these 2 points to plot. Go to my graph, start at 0, minus 4, and then I'll plot 2 minus 5, and I have a line. That's 8.1, number 9. So the key thing is, notice what kind of graph it is, which tells me that I only need 2 points. To get 2 points, you plug in any 2 x's that you like, and try to make them easy x's. Try to make them nice to plug in. It's your choice, so you should pick nice ones. Next one is 8.1, number 18. This one says, write a function for the line that passes through these 2 points. Now, as soon as someone asks you to write a function for a line, you should pick between 2 forms of a line. You have slope-intercept form. Slope-intercept form is y equals mx plus b. This is probably the one you're most comfortable with. And then there's point slope form. Point slope form looks like this. Y minus y1 is m x minus x1. Now, slope-intercept form is probably what you are most familiar with. Point slope form is more powerful, and I personally recommend it. So I'll use point slope form here. The only reason I would ever use slope-intercept form personally is if I knew the slope and the y-intercept. But this question does not tell me the slope and the y-intercept. Instead, it tells me a bunch of points. Because I have some points, I'm using point slope form. As always, this is a matter of opinion. Both of these work, and you can use whichever form you want, but I'll use point slope form because I think it's better. So what we need is we need the slope, and we need a point. So m is the slope, and the point is x1, y1. These arrows are a little bit confusing. This x1, you say x1, but you should think that a subscript is like an adjective. So this is like the first x and the first y. Whenever you see a subscript, like a little number below a variable in any class, even in a science class, you can think of that subscript as an adjective. It's something that's describing the variable. So this is x1, first x. The first x will go here, and the first y will go here. So because the question gives me some points, I already have an x1 and a y1. I'm going to say that x1 is 1. I just grabbed the first x from the point. And y1, first y, is minus 1.2. Then I have to go, all that's left to plug in is the slope. So I have to find the slope. Once you get this far where you go, oh, I need the slope, that's when you have to think, well, can I find the slope? And the answer is yeah, we have a slope formula. M is second y minus first y, all divided by second x minus first x. And I have a bunch of x's and y's, so I'll put them in the right spots. The second y is 0.6 for my question. The first y is minus 1.2. The second x is 2, and the first x is 1. In total, this fraction comes out to 1.8. So I can plug in my x1, my y1, and my m, and I will have an equation for the line. Okay, I'm gonna scroll this. I guess maybe, yeah, I can't decide if I want to scroll it or not. I guess. Maybe I'll go over here to the forms of my line and write over here. Okay, so I know x1. x1 is 1. y1 is negative 1.2. And m is 1.8. I'm keeping the x and the y in the equation because an equation of a line should have an x and a y in it. A common mistake is for students to plug stuff in for x and y, but we want to keep those around. You plug x1, the first x into x1, and the first y into y1. So here's what I have as my answer. Y plus 1.2 is 1.8, x minus 1. If I go to type that into the answer for this question, number 18, I notice that the question already says f of x equals. We think of y as f of x. So the question wants us to solve for y. So I'll solve for y before I enter the answer. To do that, I subtract 1.2 from both sides. And I'll type this in as my answer. I want to stress here that there are a lot of different ways to find and a lot of different ways to write the answer. So if you find a different source that gets you the answer a different way, or if you have a different way that you like better, just do it. That's fine. It's totally fine. But point slope form is powerful, and I like to use it whenever someone gives me a point. So that's 8.1, number 18. Next up is 8.1, 21. Looks like I already did one. Let's make a new one. This one says, find an equation of a line. Before I even advance, I have in my head that there's two possible ways I might do this. Maybe the question will give me the slope and the intercept, in which case I would use slope-intercept form. Or maybe the question will not do that, and if it doesn't do that, I will use point-slope form. Y minus y1 is mx minus x1. So let's see what I get. The first thing it tells me about the line is a point. So I'm off this. I don't want this anymore. So it tells me that x1, y1, the first point, is minus 3, 9. Then all I need is the slope. Feels like the previous problem I just did. If I could just find m, I could plug all this stuff in and I would get the answer. But instead of directly telling me the slope, it tells me that the slope is perpendicular to h of x equals minus 3x minus 8. This does tell me the slope. If you imagine a picture of h of x equals minus 3x minus 8, it would be some line that sloped downward with a slope of minus 3. So to be perpendicular to that line, I would have to be at a 90-degree angle to that line. So this is the slope information. If we can decipher this and figure out the slope, we can plug it in and get the answer for our line. Okay, well, what is the slope of this line that they're talking about? We want to be perpendicular to this slope. The slope of this line is minus 3. So my m for my answer is not minus 3, it's perpendicular to minus 3. And the calculation trick you use to turn it into, to get a perpendicular slope, is you do the opposite reciprocal. So you flip the number upside down, like you flip it, if it's a fraction, you take the reciprocal, you flip the fraction. If it's not a fraction, like this, if it's 3, you flip it anyway and make it a third. That's the reciprocal part. And then the opposite part is you switch the sign. So instead of minus, it will now be plus. So I needed the slope. I found the slope by finding a slope perpendicular to the one it told me about. So my slope is 1/3. When I plug all the stuff in, I'll have y minus 9, 9 is the y1, equals m is a third, times x minus, x1 is negative 3. The question wants it solved for y, so I guess I'll solve for y. It's going to be 1/3 x minus minus 3 plus 9. And this is my answer. 1/3 x plus 3 plus 9. Cool. Okay, 8.122. 8.122 has a huge table of stuff to fill out. Let me see if I can get a new version. Okay. It says, here's an application problem. So let me get a new sheet of paper here. 8.1. 8.122. It says, identify the information given to you in the application problem below. Use that information to answer the questions that follow. Round your answers. Oh dear. Okay. So the function p of n, I'm gonna write this one down. P of n is 415n minus 10,375. Represents the profit p of n. So here's the profit. When n computers are sold. N is the number of computers. Identify the slope. Okay, well, in this formula, the slope is like the m in mx plus b. So the slope is 415. What does the slope mean? Well, the slope has units of the y units divided by the x units. This is a really useful fact, so I'm just going to write it down here, which is that the units of m are the units of y divided by the units of x. The reason for this is because of the slope formula. Like, what was the slope formula? How did we find the slope? Well, there were a bunch of y's on top, and there were a bunch of x's on the bottom. So if we were calculating the slope in this example, we would put a bunch of y's on top, namely dollars, profit, and we would put an amount of computers on the bottom. So I would have dollars per computer. So the units of m, because of how the slope is calculated, the units of m are the units of y divided by the units of x. Or in this problem, the units of the slope are the units of p divided by the units of n. Okay, so what is the slope for? Well, the slope tells you that the company earns 415 profit dollars per computer. Okay, what's the vertical intercept? Well, they want to call it the y-intercept, but there's no y in this question. They felt like it would be awkward to call it the p-intercept, so they just called it the vertical intercept, but it's this number, minus 10,375. When I go to type in minus 10,375, it complains. It says invalid notation, so I have to read this more carefully. Find the vertical intercept, write your answer as an ordered pair. Okay, the ordered pair would be it has both the input and the output. Okay, complete the sentence to explain the meaning of the vertical intercept. Well, the vertical intercept has 0 computers and negative $10,000 of profit. That's a bad business setup. They sell no computers. If they sell 0 computers, they lose $10,375. Okay, then they want the horizontal intercept. Well, the horizontal intercept is going to be the other intercept. Instead of 0 in for the input, we want 0 for the output. I can't just grab the horizontal intercept out of the equation. The equation has the slope and the y-intercept, the vertical intercept. To get the other one, I'll have to plug in 0 for the output. So let's do that. When I'm finding something like this, I always label what I'm about to do. So I'll say vertical intercept, just so I can read my work easier when I come back to it. The vertical intercept is when the output is 0. So I'll plug 0 in for the output. This tells me how many computers they have to make to break even, to make $0 of profit. Well, I can solve for the number of computers. I'll add 10,375. And I'll divide both sides by 415. I don't get a calculator to do it. Calculator? Oh my gosh, I guess I'm gonna use my phone, of all things. 10,375 divided by 415 is 25. I was not expecting a whole number, but here it is. The vertical intercept is an input of 25. Oh no. I wrote the wrong thing. The horizontal intercept is this. The vertical intercept had an input of 0. The horizontal intercept has an output of 0. So I want 0 in the Y slot, in the output slot, and 25 for the input slot. So I'll put that in here. Cool. Then it says, what does this mean? Well, it tells you that if they sell 25 computers, the number of computers is the input, then they will earn $0. The number of dollars is the output. Finally, we have to try to find P of 31. Wait, is it finally? Oh, there's 2 more parts. Okay, so this one's find P of 31. P of 31 means plug in 31 as the input. So if I'm trying to find P of 31, I can tell that the 31 has been plugged in for n. So n must be 31. Well, I'll plug it in. I just copy down the whole formula, but everywhere that there's an n on both sides of the equation, I plug in 31 for n, and I'll get some number. 415 times 31 minus 10,375. I get 2490. When they sell 31 computers, they'll make $2,490. Ordered pair, 31, 2490. If the company sells 31 computers, they earn $2,490. Okay, finally, find the value of n where P of n is 17,845. Okay. 17,845 being plugged in for P of n now. Well, this is an equation I can solve. Notice that to solve each part, I figured out how to, like, which thing was supposed to just be plugged into which part. When it said find P of 31, it looked like 31 was n, so I put 31 in for all the n's. Here it said P of n is 17,845, so I plugged in 17,845 for P of n and ended up with this equation. So I'm writing down the whole equation repeatedly and plugging things into the right spots. Then I get some equation to solve. So I'll add 10,375 to both sides. I guess I should have opened a calculator program. I get 10, 12, 12, 8, 28, 220, and then I divide that by 415. I got n is 68. So I'll get that one plugged in. Find the value of n. Enter your answer as an ordered pair. Okay. The ordered pair has 68 for n, and the output was 17,845. Then complete the sentence to explain the meaning. Again, the dollar amount is the P of n, that's the output. So the dollar amount is always the y value, like the output value. Where the number of computers they sell is the n, that's the input. And that's it. This is a huge amount of questions and answers. It's very likely that I made some kind of error here. But because I kept careful track of my work along the way, whichever part is wrong, I'll probably be able to fix it. So let's see what happens. I got them all, but there was pretty much like, I had about a 95% chance to get each one right. And I was actually hoping I had messed one up so I could show you how to fix your answers, but oh well. Okay, next one is 8.124. Number 24 says there's a fruit company. They released a new flavor of applesauce. By the end of the first year, oh dear. Okay, that seems weird. After 1 year, the profits were $25,000. Are you okay with me writing K? I want to write K instead of dealing with huge numbers. I don't know. I'll just write 25,000. The anticipated profits for the end of the 5th year is $69,000. Assume that the rate of profit will remain constant over time. P is the profit, and X is the number of years. When it tells you that the rate is the same, like a constant rate, When someone tells you something has a constant rate, they're talking about a line. Or in the language of this section, we're going to make a linear function that has inputs and outputs with the relationship being a line. So that phrase that was the rate of profit is constant. It's a constant rate, is a constant slope, and that means it's a line. Okay, write a linear function that expresses the profit as a function of time. Whoa, okay. So what do I actually have here? I have the input is x, and the output is the number, is the money. So I think the weirdest thing here is that I think x equals 1 goes with y equals 25,000, and x equals 5 goes with 69,000. It seems like the 25,000 should be the y-intercept, but it's not. After 1 year, they made $25,000. So I believe, yeah. I believe it's like this. Let's see how it goes. So this is 2 points. Because I'm looking for a linear function and I have 2 points, I'm definitely going to look for use point slope form. Slope intercept form is good if you know the slope and the y-intercept. But here I don't know the slope or the intercept. So I'm going for point slope form. Y minus y1 is m, x minus x1. Well, what's x1? x1 is the first x. The first x is 1. M, I don't know yet. Y1 is the first y. That's 25,000. So I think the trickiest thing of this problem, if I'm reading it correctly, is that we don't know the y-intercept and that 25,000 is not b. If you're using y equals mx plus b, 25,000 is not b. I think that's the trickiest part. Let's see what happens though. I find the slope. The slope is the difference of the y's over the difference of the x's. This is 44,000 over 4, so it's 11,000. So my slope is 11,000. When I finish getting this solved for y, I'll have that y is 11,000 x minus 1 plus 25,000. Now, little problem. I am going to have it, like, it looks like there's a lot of parts to this problem. Because there's a lot of parts to this problem, I think it's worth it now to distribute this 11,000 and simplify it. So I'm going to end up with 11,000x minus 11,000 plus 25,000. And I have y is 11,000x minus 11 plus 25, that's plus 14. At the end here, I realize, wait, the output was supposed to be called P. So I'll say, oh, whoops. I'll call this P of X. So let's type in this answer. The linear function P of X is P of X equal, ooh, wait, P of X equals is actually already written here. It's just like on the original line for me. So I guess the only part of the answer I need is 11,000x plus 14,000. If I had typed the P of X equals, it should give me, it'd be like, wow, what are you doing? There's too many variables. You gave an equation, not an expression. You gave an equation means you had an equal sign and there shouldn't be one. So take this out. Then it says, use the function to predict the company's profit at the end of the 9th year. Okay, well that's x equals 9 because x is the number of years. So I'll plug in x equals 9. That's P of 9. When I plug in 9, I'm going to get some big number. 11,000 times 9. Plus 14,000. I get 113,000. Put that in. The dollar sign is already there in the question, so I don't have to write it. Finally, it says, predict when the company's profit should be 201,000. Again, the issue is I have to figure out where to put the 201,000. But 201,000 is a profit amount, a number of dollars. So I'll put that in for the profit, P of X. So all of this, P of X, is, for part C, is 201,000. This equals 11,000x plus 14,000. And I can solve for x. The first thing I'm doing here is dividing both sides by 1,000 because I'm sick of writing all these huge numbers. Now I can subtract 14 from both sides. Notice that, like, when it's an equation, you can do whatever you want to both sides. And so if you see a way to make the equation easier, or if you identify a part of the equation that's annoying, you can fix it. Like, I don't want thousands everywhere, so I divided by 1,000. It's fine. Finally, I divide by 11, and I get that 17 is x. This is the number of years, I think. I think x was number of years. Yes. So I'll plug in, I'll put 17 for the number of years. Cool. So the mistake I'm pretty sure most students are making is it looks like this 25,000 is like a y-intercept, like you might be using it for b, but 25,000 is not the y-intercept. Instead, you have a point that x equals 1, y equals 25,000. I keep saying y, there's no y in this question. They all should have been p, but nah. Okay, onward to the next one. 8.1, number 25. This says, here's a table with dollars sales in thousands for various years. Okay, so the years are like inputs and the sales are like outputs. It says, what was the sales for 2017? Well, that's, you grab it off the table. It's $36,000. How much did the sales increase each year? Oh, apparently the amount is going up by the same amount each year. So let's see how much. From the first year to the second year, it went up by, well, the difference between these two numbers. So I'll find 65 minus 36. 66 minus 36 would be 30. So it's like a little bit less than 30. You could use a calculator here if you wanted to, but the answer here is 29. Each year, the sales went up by 29,000. Then find a linear function that models the above data. Let x equals 1 correspond to 2017. So this is another spot where it seems like you have a y-intercept because you have like the starting number, but you don't have the y-intercept. You have a point, x equals 1, y equals 36. So yeah, let's use that. So we have x, we have a point. The first point we know about is x equals 1 when y equals 36. We can use this to build an equation of the line. I'm using point slope form. y1 is 36. M is the amount that things are increasing by each year. My answer to B was 29. The y and the x in point slope form I'm keeping because I expect those in my final answer. And then x1 was the first x we knew about, which was 1. I can finish solving this. Because there's more parts after this, notice that I'm actually bothering to distribute this stuff because there's more parts after this. If all we wanted it was like the final step of the problem was the equation of a line, an equation of a line, then I would just add 36 and be done with it. But because there's more parts, I'm going to work on it a little bit, make it a little bit better. So in the end, I have y is 29x plus 7. Last thing is find the sales in 2024. Now, this is a little bit tricky because x is not the year. X equals 1 is the year 2017, according to part C. So we need to plug in 2024, but I need to know what x is so that I can actually plug x in. Okay, well, x equals 2 would be 2018. I need to get up to 2024. Okay, if I go 2 more years, that's x equals 4. So, okay. So it's 2017, 18, 19, 2020, 2021, 2022, 23, 24. So I think it's x equals 8. Let me see if this works. The issue is just that x corresponds to something other than exactly what the year is, because the problem told us that x equals 1 was 2017. So for part D, x equals 8 goes with 2024. So I will plug 8 in for x. To get my answer. 8 times 30 would be 240. So this is 232. So in total, I get 239. You can use a calculator, so don't worry about any mental math trick I use. That's not the point of the problem. The point of the problem here is that none of these are x equals 0, so none of these are the y-intercept. So you kind of need to use point-slope form, or you need to be very careful about how you're finding your y-intercept. The y-intercept turned out to be 7, and we're able to get the answer. Cool, that's 8.1. Let's look at 8.2. Specifically 8.2, number 8. So if you were here for the very first problem in this video, or maybe it was the second one, we were talking about domain. Domain is all the x's, like all the valid inputs to the function. All the x's you can possibly plug in. Here we have the function f of x is 1 over x plus 21. And you might think, what do you mean all the valid inputs? I can plug in whatever I want. If I plug in x equals 3, the function makes an output for me. Like, what could go wrong? What could go wrong is the question you want to ask yourself when we're looking at domain. Like, what could go wrong with a fraction? The thing that could go wrong with a fraction is we don't want the denominator to equal 0. If the denominator equals 0, the function will try to divide by 0, and I'm not interested in that. The function is not going to work if I try to divide by 0. So I literally take the denominator, and I say the denominator is not 0. And this gives me my answer. X is not minus 21. The question, however, wants me to give this answer in interval notation. So I recommend to get an answer in interval notation, you draw a picture of all the numbers you're talking about. Here's all the real numbers. Minus 21 is over here somewhere, and I am explicitly removing minus 21 from the answer. Minus 21 is not invited to the party. Everyone else is. Minus 21's worst nightmare. Then you can scan across the picture from left to right to see all the intervals that are involved. There's the first interval over here and the second interval over to the right. The first interval starts, we're scanning left to right, the first interval starts at minus infinity and goes up to minus 21. Oops. And the second interval starts at minus 21 and goes all the way up to infinity. The last thing you need with interval notation is you have to decide whether the endpoints are included or not. If they're included, you use a bracket, and if they're not included, you use a round parenthesis. Minus 21 is not included. That's the whole point of all this, so I put parentheses for minus 21. Infinity and minus infinity are not even numbers, so they're not invited either. So we use round parentheses for those as well. Finally, if you end up with multiple intervals that you want to bring both of them along in the answer, you combine them together with a union. And this is our answer. To enter this stuff, you have to click in the answer box and choose interval to get like the tools you need. I need parentheses from -infinity, comma, -21, then a union, u. Does it let me write a, yeah, we want this u, this union u, like it's not a lowercase u. Then some more parentheses, and I want from -21 to infinity. Okay, on to 8.3. First one I'm supposed to look at is number 6. number 6 says, complete the description of this piecewise function. This piecewise function is made of a bunch of line segments, so this will be a bunch of questions that are find an equation for all these lines. Okay, it says, well, you want some formula f of x equals something for this range of x's, f of x equals something else for this other range of x's, and f of x equals another thing for this last range of x's. The easiest one is a horizontal line. A horizontal line, they all have the same y coordinate. These are all at y equals -2. So for that part of the graph, which is this part, y equals -2. Cool. I like to do the easy part first. Then I need to find an equation for this line over on the left, and I'll put an answer here, like a rule for it here. So let's try. This line stops at the point x equals -2, y equals -1. Okay, so this is we'll do the left piece. It has the point -2, -1, and it also has other points. Let's try to find another nice point on the graph. Kind of miss. It looks like it hits at -4, 4. X is -4, y is 4. Whatever version of the problem you have, you want to look for points that actually the line perfectly hits the grid. Mine perfectly hit the grid at x was -4 and y was 4. I take these 2 points and I find an equation for a line between them. Guess what? I'm using point-slope form. The first y I found was -1. The first x I found was -2. And the slope, well, I don't know the slope right now, but I can go get the slope because I have 2 points. With 2 points, I can find the slope. It's the difference of the y's over the difference of the x's. For my slope, I got 5 over -2, which I can write it a little nicer as -5/2. That's my slope. To finish writing it in the form y equals something, I need to fix this up a little bit. But because there's no other parts of this problem, I'm not going to bother distributing the -5/2. I don't feel like it. I'll just solve for y, and I'll call it good. So this is the first piece. Y equals -5/2 x plus 2 -1. Type that into the first piece. -5/2 x plus 2 -1. Then the last piece is also a line, so I'll find an equation of this line. Guess I'm scrolling again. Okay, right piece. It's a line, so I'll try to find 2 points that line up on the line. The end point is at 1 -3, and the other end point, oh, I don't have another end point, but I look for another point where it perfectly hits the grid. It looks like mine hits at 3, 1. Combining these two together, I can get a slope, and then I can use point-slope form to get an equation of this line. This one comes out to have a slope of 2. So I can use point slope form. Y minus the first y is the slope times x minus the first x. I'm being lazy. I'm not distributing the 2 because I don't have to. I just need to solve for y. So the last rule here is that y is 2 times x minus 1 minus 3. That's number 6. Let's look at number 7. What's going on here? Got a bunch of stuff on here. Okay, this one goes the opposite direction. Oh, let me clear off my paper here. So this is 8.3 number 7. 8.3 number 7 is kind of the opposite direction of 8.3 number 6. Instead of showing us the graph and asking us to make equations, instead the problem gives us equations and asks us to draw the graph. So I need to read what's going on here. And to read what's going on here, I read it as, oh, well, y is 2 if x is less than or equal to minus 1. Y is minus 2x plus 1 for this other range of x's. And y is 2 if x is above 1. So I have 3 pieces to plot. The piecewise function notation that has this big, like, scary looking bracket, it's just shorthand for this, that there's 3 rules, and they're all y equals. So we try to save a little bit of space by just writing the y equals one time. So what does y equals 2 look like? Well, y equals 2 is a horizontal line at the level y equals 2. So I'll draw a line segment. I want to draw across y equals 2. But I only go to the left of x equals minus 1. This says I want x to be below minus 1. So I start, where was I? Y equals 2. Okay, so y equals 2, but only to the left of minus 1. So I go over here and make this line segment. To be very clear about what's happening, just like in the video for this section, the video for this section said to be very clear about what's happening at the endpoint. Is x equals minus 1 included or not? And here it is included because of the less than or equal to. So I make a dot at the end. Then I need to plot the second part. The second part says y equals minus 2x plus 1. That's a line. Because it's a line, I only need to plot 2 points. So let me find 2 points. One useful trick is that you should always plug in the endpoints, because those are the guidelines for like what's going on here. So plug in the endpoints. I'll plug in minus 1 and I'll plug in 1. When I put in minus 1 for x, I get 3 for y. And when I plug in 1 for x, I get minus 1 for y. But you should have a complaint about what I just did. I said plug in 2 points in this range, and then I picked these 2 points because I said always plug in the endpoints. Your complaint should be, hang on a minute, x is supposed to be more than minus 1. There's no or equal to here. You aren't allowed to plug in minus 1. And I say, fine, 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 I'll put an open circle when I graph this point, because x is not really allowed to be minus 1. So let's do it. I'm going to draw a line segment between minus 1, 3, and 1, minus 1. But that first one was supposed to be an open dot, and the second one can be a closed dot. Finally, the third part is y equals 2 again. So I'll go up to y equals 2, go across for all the x's that are greater than 1. And then I just want to be very clear about what's happening at the endpoint, which is x equals 1 is already spoken for in a previous rule. So I need an open circle here. So you go through all the parts, like all the pieces of the piecewise function, graph them all separately. Some of them are horizontal lines, some of them are lines that have a slope, like a slope minus 2. plot all the endpoints and be very clear about whether the endpoints are open circles or closed circles. That's number 7. Onward. Number 9. Okay. In 8.3 number 9, it says, describe how the graph of the function y equals x minus 2 can be obtained from one of the basic functions. So the idea here is that the minus 2 is a transformation that took a regular old graph y equals x, which is like the simplest possible line. It's a line that, well, that's not true. It's our simplest possible slanted line, maybe? It has a slope of 1. It goes up at a 45-degree angle. To change from y equals x to y equals x minus 2, there's just a minus 2 tacked onto the end of the function. So that moves the function down by 2. This perspective that we should memorize a bunch of simple functions, like we should memorize 10 shapes, and then move those shapes around, is the idea of transformations of functions. Memorize y equals x. That's our starting function. And then shift the graph 2 units down. Then it wants us to draw that. So y equals x would have gone through, it would have gone like this at a 45-degree angle, but I'll move it down by 2. Oh. Okay, let's try that again. I'll go down by 2 and then go up at a 45-degree angle. Maybe that's a better way to do it. I wonder if I could graph y equals x, like a normal y equals x, and then just grab all the points and move them down by 2. Oh, that's pretty cool too. So this one is y equals x down by 2. You can either plot some points to get y equals x and then actually move them down, or you can start at minus 2 and go at a 45-degree angle. Either of those works. This one says, what's up with y equals square root of x plus 4? Well, that's y equals square root of x. And there's just a plus 4 on the outside of the function, so that moves it up by 4. So let's do it. I'll have regular old square root of x. And then I move the whole, so regular old square root of x goes through 0, 0, and 1, 1. And then I'm moving all the points up by 4. And that's my new graph. For that one, the moving it up, like placing the base graph and then moving it is a really good way to do it. Notice that when it said square root of x, I picked the one that I knew was the square root of x. So like in the video, there's just a few shapes that you need to like know what they look like. There's only 8 or 10. And you memorize those, and then other functions like square root of x plus 4, you can know their graphs because you know the base graph and you move it up by 4. That's 8.3, number 9. Last one's up next. It's about shipping. This is 8.3, number 20. 8.3, number 20 says that there's a shipping company whose shipping rates are based on the weight, and they give 3 rules based on the weights. So I'm expecting a piecewise function because it's one function, but it has 3 rules. So what do they do here? Well, they charge $0.5 per pound. What you need to start noticing is that because the units of slope are the y units divided by the x units, anytime you see anything that has units that are like a fraction, you should suspect that that might be a slope. So for example, this says $0.5 per pound. That implies that the dollars are like a y and the pounds are an x, and $0.5 per pound is our slope. The flat fee of $2.50, that's a y-intercept. It's not a rate. It's not like dollars per pound or pounds per dollar. So that formula for the first rule, $0.5 per pound, is a slope. And the flat fee of 250 is the y-intercept. For the second rule, it gives me another dollars per pound, which is a different slope. And the same flat fee, I guess, 250. And then in my problem for the third part, the slope is $3.25 per pound for the third part, and it gives me a different flat fee. Okay, well, this is going to give me 3 different lines. I can put these lines in, I guess. I'll have 0.5x plus 2.5 using slope-intercept form. I'm just doing y equals mx plus b. Y equals mx plus b. But then it says, well, for what intervals? Oh, okay. Well, this interval says from 0 pounds up to 7 pounds. So this one is the interval from 0 to 7. To enter an interval, you have to say whether the endpoints are included or not. And an endpoint that's included has brackets, like square brackets, and an endpoint that's not included has parentheses. Here it says from 0 pounds, that sounds like it includes 0, and up to 7 pounds also sounds like it includes 7. The second rule says over 7. Okay, over 7 does not include 7, so it's a 7 but with a parenthesis. And less than 14 does not include 14, so the 14 also gets a parenthesis. Finally, this one is from 14 pounds up to 83 pounds. That sounds like both of them are included. So they'll both get square brackets. Finally, it says, how much does it cost to ship a package that weighs 5 pounds? Well, the 5 pounds are the x. So we need to plug in x equals 5 for the last part. The issue is I have 3 formulas I could try to plug it into. Like, which one do I plug it into? The answer is x equals 5 is in one of those ranges, between 0 to 7, or 7 to 14, or 14 to 83. And those ranges tell me which equation to use. 5 is in the first range. It's in the range from 0 to 7. So I'll use the first formula. I'll use c of x is 0.5x plus 2.5. Here x is 5. So I'm plugging 5 in for x on both sides of the equation. And I end up with $5. Wow, that's a messed up 5. This is $2.50 and this is also $2.50. So I end up with $5. That is it. Feel free to keep sending me questions. The way that these questions were chosen were people clicking this button, message instructor. So send me more. See you in class.